Namaste. Okay, guys. This is let's see. We're winding down. It's June. We have two lessons this week, and one the week after that. This is pretty much going to be the last video. Okay. Here's your assignment for today. What we're going to be doing is we're going to be doing second law problems. All right. Problems that involve the equation F equals ma. All right, which is Newton's second law. And I'm going to show you how to do them right now, or how to use the equation right now. All right, so here is Newton's second law. F equals ma. F stands for force, and m stands for mass, and a stands for acceleration. And what the equation means from previous lessons, all right, on Newton's laws, is that a net force on a mass causes the mass to accelerate, either speed up or slow down or turn in some way, okay? So when you're doing these problems, if you are asked for a force, right, you would just use this version of the equation. And just like the acceleration equation, you can take this, this particular equation and manipulate it depending on what you're looking for. If in the problem, if you're asked for the object's mass, then you could rearrange this equation and it would look like this. Mass is force divided by acceleration. So if you're asked for the mass in the problem, there we go, then you would use this version. If you're asked for the acceleration in the problem, then you can rearrange it again and it would look like this. So A is equal to F divided by m. And that's if you're asked for what is the acceleration, okay? And again, this is, you would use this version if you're asked what is the force, all right, on an object. Okay, so let me just do a quick example, all right? So make sure you have these down because I'm going to erase them so I can do an example for you. All right, so let's say that we have a car and the car has a mass, and I'm just going to draw the crappiest car in the world. So the car has a mass of 1,000 kilograms, okay? All right, and let's say that the car has, let's see, it accelerates with an acceleration of 3 meters per second, okay? And what we want to know is what is the net force on that car that's causing it to accelerate at 3 meters per second. Okay, well, the 1,000 kilograms is a mass. The A is 3, so, and I'm looking for a force, so I'm going to use the first version. Okay, so the force on that car would be the mass times the acceleration, which would be 1,000 times 3 meters per second squared, and that would give me a force of 3,000. And the answer comes out in the metric unit of force. If we're using meters per second and kilograms, the answer comes out in the metric unit of force, which is a Newton. So there would be it would be a 3,000 Newton force would cause on a 1,000 kilogram car would cause it to speed up at 3 meters per second every second. So it would get faster at 3 meters per second every second that it's traveling. Okay, so let me do another example. So let's say we have the same car, and so same car, and let's say that we're going to put a 5,000 Newton force on it. Okay. All right, so what, actually I don't know why I put a question mark there, probably because it's morning and my coffee hasn't kicked in yet. So we're going to put a 5,000 Newton force on it, okay, like that. And what we want to know is how much is that 5,000 Newton force going to cause the car to accelerate. So what's the acceleration of the car? And then we're also going to ask something else, all right? We're going to ask, like, okay, how fast is the car going after a time of, let's say, 8 seconds, okay? So let's see how this works. All right, so what I want to do is, all right, first thing I want to do is I want to find the acceleration of the car. So I'm going to use the other version of the second law. So A is equal to F over m. So again, it's the same equation as F equals ma, it's just rearranged, okay? And I'm going to find the acceleration. So that's going to be let's see, 5,000. I'm using easy numbers here. Newtons divided by 1,000 kilograms. And that's going to give me an acceleration of 5 meters per second squared. So it's going to get faster by 5 meters per second every second that it's moving. Okay, great. So now the second part of the question is like, well, okay, so how fast would the car be going after 8 seconds? Now for this, we're going to go to, and you want to open up your notes to the previous lesson, okay, on acceleration, and we're going to use the acceleration equation. We're going to use the version that looks for the final velocity, which looks like this: Vf is equal to Vi plus A times T. Okay. All right. So doing that, we're looking for the final velocity. If you're starting from rest, the initial velocity is 0 plus A is 5 meters per second squared, and T is 8 seconds. So this is, and make sure we got enough board space here. So this would be 0, okay, 5 times 8 is 40 meters per second. So the car, if you put that force on it, is going to speed up at 5 meters per second squared, and after 8 seconds, the car will be going 40 meters per second. Okay, so that's kind of more like a two-part problem, and you're going to have a couple of these in the problem set. But I tried to keep it kind of light because I'm not there for you other than during the office hours. All right, so you know, we'll make do. All right, so do your best on this. See me during the office hours. Try the problems, and again, check in, and good luck with that. Okay, so and remember also to enjoy your apocalypse. I know I am. All right, goal us out.